So thank you guys. I'm glad to see there are still many people left since this last session. So now let's begin. My name is Norman and I'm from DJI. I'm a system architecture engineer, and the key point of this presentation is quite simple. Oh, sorry. We designed a drawing for ROS. We call it Matrix 100. And I want to introduce you guys the drawing because I believe many of you guys are not familiar with it, because few people are from the aero robotics development. And I want to prove that the drawing is very powerful. So now let's begin. So first I will talk about the hardware part, the technical displays, and then tell about software part. We have a protocol and we pack the ROS package for it. We call it onboard SDK. And then I will share some developer stories to prove that the drawing is very suitable for the ROS developer and it's very powerful. And then we'll tell about some future maps. So let's begin. I believe that many of you guys sitting here have already known about DJI, or at least heard of some of our products, like the Phantom, like the Inspire, and the latest one, the Mavic. And we also have a drawing for developers. We call it Matrix 100. And this drawing is neither famous nor selling well, but we are trying our heart to working on it. And the motivation to build this drawing is very simple. We received many inquiries before we launched the Matrix 100. Some of the people are from the university laboratories or some research institution, and they say that, "Hi DJI, I have some algorithm related to the navigation or the path planning, but I don't have a platform to test it because I don't want to build a drone from the controller, the beginning of the controller, and then imply my algorithm. I want to use your platform. I saw your drawing quite good." So unfortunately, at that moment, they can't. And the other group of people say that, "Hi DJI, I'm doing some drone-related business, such as power line checking. That is a drone with camera will fly over the power line and to check if there are some wrong with the power line or it's good." So after we received lots of these inquiries, we decided to build a drawing for developers so they can build their own things on our platform. Then we launched the Matrix 100 and answered them, yes, of course. So the Matrix 100 is very accurate, stable, and reliable compared with some open source solutions. Because DJI is very professional in aero photography system design, we use our technology in the controller and in some smart navigation. Then we build this drawing for the developer. And we also have a serial port. So the developers can talk to the serial port directly by the raw data. And we call it the onboard SDK. We also build a ROS package for it. I will talk it later. And then the developer can install his own NUC or some onboard embedding system on the drone. We have extra space for extra sensors and extra NUCs. And we have a camera with gimbal. Developers can get a live video directly. It's about H.264 format. And the last one, we have a guidance system. The guidance system is a stereo camera, and you can get the disparity, the depth information from the camera directly for your own vision-related algorithm. So let's move to the software part. What can the onboard SDK do? First, the most basic thing, flight control. You can ask the drone, for example, to fly forward in 5 meters per second, or ask the drone to fly to the east 6 meters. And you can get the real-time data from the broadcast from the Matrix 100. For example, what is the current velocity, the current quotidian, and even how many % of battery left. And the most important one, I think, is data transmission. We call it a data link. You can talk with your, it's not you, your NUC or your onboard computational device can talk with your mobile device directly by the data link, which means you can choose different tasks or different functions by pressing the screen of your mobile instead of some SSH or remote desktop by the Wi-Fi or some buggy wireless serial port. And the range is about 5 kilometers. And the last one, we have a camera with gimbal, so you can get the live video and control the camera and to make it look at the exact angle and position you want. We also have a ROS package for our onboard SDK. The reason is quite simple, because At first, when I talked with some of the researchers from the university, they told me they don't have too much embedded system programming background. They are all working on the high-level algorithm design. So we think we need to do the most painful part for them, that is talking to the serial part in raw data. So there are about 6 packages we provide for the ROS users. There are 5 listed in the official repository. The last one not because of some third-party library dependencies issue. So the most important one is the DJSDK package. It has nothing to do with ROS actually. We just put it into the catechin workspace and make it a ROS package. It talks to the serial part directly with raw data, like I send 0xAB and 0xCD for one command, and 0x01, 0x02 for another command. And this one does this kind of thing. And it's a library actually. So the DJSDK package is a translator to translate what DJSDK lib do to the ROS language. That is the topics, the services, and some action labs. And the DJI2 map is a package that we translate the DJI Open SDK protocol into the Mavlink protocol. So Mavlink is very popular in the open source area when users working on the join. So we also want to combine the open source community with us. So we design a package that's translating the Mavlink protocol into our protocol and our protocol into the Mavlink protocol. So the last one, the web ground station, is a web page-based ground station. You can put your waypoints on a map, maybe the Google map, maybe the Bing map, and then the drone will fly through these waypoints. We use some, I forgot the package name, but it's ROS script. And the last one doesn't show in this list is a camera node. It reads the H.264 format video from our camera and then publish it into the ROS network. So this is the whole structure. Forgive my ugly painting. And you can see it's layer by layer. Okay, where's the mouse? Okay, this one is a drone. And the drone, there is a serial part and a camera part. The serial part will talk to the DJSDK lib, and there is a hardware layer, the medium layer, and app layer. We call it application layer. And then the DJSDK will pack all these things into the ROS language. That is the topics, the service, and the action service. So there is a publisher, there is a service server, and the action lab server. And we also wrapped a header file. We call it djjoin.h. By this file, the developers can use our code directly, although they have no experience with ROS. It's just an OOPV. Oops. So the question is that many people ask me why did I want to write a ROS package for our drone? The first reason is quite simple, because ROS is very popular in DJI. Actually, most of our developers had experience with ROS, and we use ROS as framework to code and use ROS as debug to test as RVs like the gazebo. And so we want to introduce ROS to our developers. And the second reason is we think that ROS is a universal standard between developers and us. We are also developers, so it's a universal standard between developers and developers. So developers and us are following the same communication protocol, so they don't need to learn about our new onboard SDK protocol. If they have some experience with ROS before, they can use our package directly and to control our drone directly. So developers can play with the topics, services, and actions we provide directly without caring about how our code works with the matrix 100. So this is an example that we isolated and modular different packages. First, the service client will send some requests to the service handler. The handler will draw the callback function. The callback function will to find the corresponding application layer in the library, and the library will give it to the medium layer. The medium layer will translate it into the hardware language, the non-hardware language, the serial part raw data. And the raw data will be sent to the drone by some library in different platform, maybe the Linux platform, maybe the Windows platform, and some STM32. Okay, sorry, no ROS in STM32. But the hardware layer is different in different operating systems, so it's isolated. And our ROS is easy to use because we wrap the DJI join.h header file and DJI join.py for Python users. The developers can include these two files and use them in their code directly. It is an implemented subscriber, service client, and action lab client. Here you can see the example. First, this is some private member of a class, like presenting the join status, like the attitude quotidian, the flight status, and the gimbal info, the royal pitch. And this is the callback function of the subscriber to update this variable. So once the developers call maybe the join.attitude, then they can get the latest attitude without caring about how this is implemented if he has no experience with ROS before. And this is the control part, the service, and it can just tell the DJI join.h, hi, I want the join fly forward in 10 meters per second. Then we will translate it into the ROS subscriber, and the subscriber will send a request to server. The server will do the control part. And also, our code is a good tutorial, I believe that, because I talk with many people that doesn't have ROS experience before, and after they using our code, they say, whoa, ROS is quite simple. The wiki is there are too much things in the wiki, so they cannot find the most important area. So in our code, we implement the topics, the services, and the action labs, and several other components, and put them in different files. So the users can study on ROS for hands-on ROS directly by our example code. And we also code in 3 different languages, the C++, the Python, and the JavaScript. And all these three languages works well, and we put them into the same ROS network, so the developers can know how to do one kind of thing by ROS in what kind of way. And so the code part is done. So I'd like to share some stories from our developers. Some of them are from the business, and some of them from the university. So they all use Matrix 100 to do their job, maybe to making money or maybe to publish paper for research purpose. So Sky One is a company in America, and they are combining the join with the VR and using the virtual reality, like the HTC Vive. They use it to do the path planning, like they put some cases in the air by the VR, 1, 2, 3, then there will be a path passing through them, and then they will pass the trajectory to the drone, and the drone will follow the planned path, and the camera will look at the exactly same angle. So in this in this video, you can see the below one is the trajectory they planned in the HTC Vive, but above one is the real footage they have shot from the drone's camera. So you can see they are exactly the same. And by the way, they didn't use the Matrix 100. They are using Matrix 600 instead. It is another platform support. It's another platform from DJI, also support Armor SDK, but has more payload. So you can add your own camera on it. So maybe for some movie makers, they want to install the RED camera on the drone, and they can choose the M600 and use these tools to do the path planning and do the shooting in reality. So this one is called Hesai instrument. They use some laser-based method to measuring the air quality. So they need a flying platform. So it's a drone-based air quality measurement system. So they can measure the air quality of a building through windows by flying the drone directly without caring about, they can do it directly without going upstairs and downstairs on foot. So this is all automated work because we provide them some interface to control the drone fly in a certain way, and it's very convenient to use. And these 2 videos, I found them from the ROS paper submitted this year. And the left one is some visual odometry, and the right one is some online path planning method, and they all use the Matrix 100 as their platform to test their algorithm. I know the author of the right one and asked him how do you feel about Matrix 100? I think it feels good because it doesn't care about how to control the drone. I mean, it doesn't need to care about how to design controller of drone, stable controller. He just need to call our APIs and the drone will fly exactly as what he wants. And these two pictures from this year's International Air Robotics Competition, you can see that we found that most of the teams, about 8 out of 10, they use our drones as their platform to modify. They do some mechanical change, so the Matrix 100 is not what we sell, but looks weird. So, and we also hold our own competition. We call it SDK Challenge. In this challenge this year, the drone need to automatically landing on a moving vehicle, and there is also some other tasks for vision-guided flight or object recognition. The price is about 100,000 US dollar, and it will also hold this year. So if some of you guys are interested in earning money for the prize, welcome to join the competition. We will provide the equipment for free. And this is what the competitors done last year. The above one is a video that the drone is landing a moving object. They all use April tag. So, and the above one, the below one is the drone is tracking an April tag. This guy is running very, very fast. And the drone is faster. You can find the drone's lag on the video. You can see the camera is looked at closely and they didn't lose the object. Now I will talk about the future map. The future roadmap, DJI is always trying to involve more engineering students that are interested in robotics to join this area. So we hold our own, we call it summer camps. And in this camp, the students from different colleges all over the world should working on some certain problems. For example, this year they need to modify the Matrix 100 to pick up some, maybe it's like a toy, I don't know what it exactly is. So, and put it in some certain position. And we will hold it every year to train the young college students to involve in the robotics area. And we also cooperated with some university laboratories. And we want to bring our devices, equipments, maybe the Matrix 100, maybe some other things to the laboratory. So the laboratory can have some platform to test their algorithm, can do some projects. And I think the most important one is the developer community. So we are trying hard to put more attention on the developer community this year. So first, maybe provide more technical support, then maybe some more showcases of interesting projects from our developers. And we also have some plan for the industrial application and enterprise solutions. You can see this one is an M600, you saw it in last slides. And we also have a controller called A3. These two are for the industrial purpose. So you can, some business companies, drone-related business companies are using this tool to design their product and selling. So I'm a little fast. So first, thank you all still staying here to listen to the last session. And we are working hard to provide the best software and hardware experience for our developers. DJI also pay great attention on the developer instead of the normal marketing, because we think that making money is yeah, I just talked with the guy from Parrot in the counter. He told me that DJI is evil. DJI is always making money, but actually we also pay more attention than the marketing on the technology. So that's the reason why we design and release the drone Matrix 100 to the developers. So we want to involve more people in this area, in the aero robotics area. And we use ROS, we love ROS, then we design a drone for ROS. That's quite simple. So thanks, that's all. Any question? Oh. Maybe this one.
Hello. So yeah, I saw that on the website that the SDK is compatible with the ROS Indigo. Are you planning to release the kinetic compatible?
Actually, you can compile the code from the source. It's open source in the GitHub, so it doesn't matter which version of ROS. Actually, I developed it in the ROS Hydro.
Okay. All right. Thanks.
Sorry? What?
The question was, will it compile in kinetic? Do you know?
Yeah, it should be. We have someone working on the kinetic support, but I haven't talked with him. It should work.
The work, and I'm very happy to see like DJX actually leading the consumer UAV industry. And one quick question is like, have you already made some URDF model for your drones, or do you have any plan to like?
We have the URDF model, and it works in the RVs and maybe not Gazebo. I don't remember. We have the model. It's in the GitHub.
Thank you.
Excuse me?
Yeah.
Thank you very much. Thank you very much for your introduction. I already bought 2 of the DJI's Matrix 100, and we want to access to the data of manifolds, that is ZEMS. I think the camera's name is. But it seems, because we want to encrypt with the new TX1 from NVIDIA, the computer, we want to get the data, and it seems we can't get the source code. So do you provide those kind of things?
This is a most important complaint from our customers. We have received many of these cases. Actually, we want to release the camera code, but unfortunately, to decode the H.264, we need some hardware chip from NVIDIA, and this library is not open sourced, so we cannot open a solution to the developers how to decode the media from DJI. We have some software way, but the latency is terrible, so we have to design onboard computer called Manifold to sell it to our products, to our customers.
Okay. It is appreciated if you can provide some libraries that we can, to answer our requirements, like if we want to use this kind of platform.
We want to provide, but there's some license problem. I talked with them, but they said we can't. Sorry about that.
Okay, thank you very much.
All right, thank you.
Thank you.